Alright, let's assume the bacteria are shrinking exponentially and you measured 81 bacteria after 2 hours and 27 bacteria after 3 hours. We want to write an exponential equation for this scenario and then find out how long it takes for there to be one bacteria left. Alright, so the basic way you want to do this, you want to start off and realize, okay, at 2 hours I have 81 bacteria. So at 2 hours, that's time, I have 81 bacteria. And then at 3 hours, I have 27. So at 3 hours, I have 27. Those are the two pieces of data you have, and you're going to want to make an equation like this. Y equals AB to the x. That's called an exponential growth equation. Or decay. This one is a decay, actually. Now, so let's start off with, okay, if we know these two values, okay, what I do is I make a table. I'm do time versus number of bacteria. And then I put 281 right here and put 327 right there. Now all these green values right here are calculations that I figured out. And the way I did that is I basically looked, okay, how did I get from 81 to 27? What I noticed right here is I took 27 divided by 81. That means I got a third. So basically I divided 21 by 3 to get 27. So that B value is this value right here. As you can tell, that's the rate, the decay factor of this exponential decay. So that 1/3 is again how you got from 81 to 27. And you just divide the two numbers. So from that I got my B value. Now my A value. My A value is my initial value, what I started with. How many bacteria at time 0. So if we're dividing by 3, once you multiply 3 this way and multiply 3 this way, because if you divide this by 3 you get this, divide this by 3 you get this. So what I do is I just multiply by 3 this way and I got to 729. That's my initial amount, which would be my A value. So right there, 729. My decay factor is 1/3. That's B. So I have my equation. Now if I want to find out when I have one bacteria, I could put a 1 right here and solve. That's actually, I think, a little bit harder. I technically would just, okay, instead of putting 1 there, what if I just kept my chart going until I got to 1? So I divide by 3, divide by 3, divide by 3. Oh, there's one bacteria. Hey, that's 6 hours. So how long will it take for there to be one bacteria? 6 hours. Okay. So an overview, you take the data given, make some coordinates, make a table, you work your way back to 0 time, and then you look what they want in the future, and you kind of calculate over, and you can get your basic equation and the answer to the last question on how long it takes for getting a certain amount of bacteria.